Here we go, I think. I haven't heard the ding, but I think we're live. Who's my favorite student? Good old Anne. What's the name for the theory of the origin of the universe? The Big Bang Theory. On your test, I'll probably ask you to explain it a little bit. For example, you actually didn't get it. And I forgot to give you the quiz thingy. Okay, let's pause. As I was saying, Lena, my joy, what else should you know? The reason we believe that the Big Bang Theory is correct is because the universe is, there's a word I'm looking for that begins with EX. Okay, that you need to know. Do you know the scientist that discovered that? I'll give you a hint. We named our space telescope after him because of his discovery. Hubble. Okay, so Hubble. Hubble discovered in the 30s that the universe is expanding. And the fact that it's getting bigger suggests if you go backwards, it must have been once in a small, tiny, big ball of matter and energy. Number 2, which of the following are correct in order of size from smallest to largest? Okay, a nebula is bigger than a star, so that's wrong. A galaxy is the biggest, so that's because it says smallest to largest. Planets are not bigger than stars. You know what? The answer is D, and I'm not even really needing to read it, but I'll double check. Planets are smaller than stars, which are smaller than nebulas, which are smaller than galaxies. D. Which of the following led Edwin Hubble to propose that the universe was expanding? We talked about redshift. He noticed that when he looked at most galaxies and when he looked at the light from most stars, they were shifted to the red, and what that means is, they're receding away from us. It's the same phenomenon that makes you, when you hear a train go by or a car go by, the sound changes in pitch. The sound actually isn't changing. What's changing is its shift relative to where you are. Hey, what kind of galaxy is the Milky Way? Spiral? Which one of those is not a type of galaxy that I mentioned? D. I never said there was spherical. Elliptical, some of them can look like spheres. Which one of these has the oldest stars? Spherical is hysterical? Is that what you said? Yeah. And that's why you're part of this class, Aiden. Thank you. Try the veal, tip your waitress. Okay, here we go. A little comedy routine or something like that. Hey, what force holds the stars in a galaxy together in a group? This one I didn't do a big song and dance. I'm just kind of hoping you know. Jordan. Gravity. In fact, what we think, Jordan, is at the center of each galaxy is a super massive black hole. Huge. And that's what's actually causing all the stars in the galaxy to either spiral, if it's a spiral, or just clump around it if it's an irregular or an elliptical. Have we seen it? We can see the deflection of stars by that force of gravity. So we can detect black holes indirectly, and they give off X-rays. Sorry, I shouldn't say. Black holes don't give off X-rays because nothing escapes from a black hole. Black holes cause X-rays to form right nearby them from other objects. Got to pick my words carefully, nerd trivia. What does it indicate if a galaxy is if light from a galaxy is shifted to the red part of the spectrum? What'd you say? Yep. Away. What if it's shifted to the blue part of the spectrum? Coming towards us. Okay? So red shift and blue shift. You'll have to come up with your own way of remembering that red means going away and blue means coming towards, but such as it is. What's a star cluster? What'd you say? Okay, it's definitely not the energy released by a single star. That's a supernova, I think we called that. A group of galaxies? Nope, that's a galaxy cluster. Pattern of stars. By the way, what do we call a pattern that stars form when viewed from the Earth? You haven't given this word yet, but you know it. It begins with the letter C. I'll give you an example. The Big Dipper is one. What do we call them? Yeah, constellations. That's actually the next chapter. So, C. What name do we give the dust and gas found throughout space? We call that interstellar matter. By the way, answer C, background radiation. We can detect that. That's the leftover radiation from the Big Bang. That's one of the other evidences that there once was a Big Bang, that the universe started like that. We can detect the cosmic background radiation. Put your pencils down. Show you that some other time. That's Physics 12. I was going to show you a video. I can't find it. I'll grab it up later. Hey, what's the nuclear reaction in the sun that produces energy? Fusion. Fission, which is the next one, that's what we do with an atom bomb. Fission is splitting an atom in half. Fusion is crushing two atoms together. They're opposites.
I'm just going to go fishing.
You're just going to go fishing? Uh-huh. Just, you're on a roll, Aiden. You're on a roll. Why do astronomers call black holes black?
No light can escape their gravity.
A. What are the dark areas of the sun called? Sunspots. I think all four of those words would be fair game for your vocabulary on your test. So you need to know what corona is, sunspots, solar flares, and prominences. No, but that's where they took the name from. What unit is described as the average distance between the sun and the earth? D. What's the abbreviation for an astronomical unit? AU? A-U. No? Okay, fine. I got to catch up to Aiden. Which of the following planets has water on its surface in 3 states? Now, this is from the planetary summary assignment that I gave you that some of you still haven't done. Which planet has water in all 3 states? Earth does. Okay? Mercury has ice in its craters. We found that. Jupiter, Venus are a little weird, but Earth. Which of the following planets has no moons? Venus has no moons. Mars has 2 small ones. Earth has 1 big one. Neptune, I think, has a bunch. Which of the following is considered an inner or terrestrial planet? Nope. 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 Yep. Yeah. I'm sorry, I was just doing, I often go process of elimination on multiple choice just so that I know I'm getting the right answer. Especially you guys are going into grade 10, you have those provincials which are mostly multiple choice. A lot of the time you don't even need to finish the question. If you always cross out wrong answers as you know they're wrong, you'll often end up, oh, I only got 1 answer left. I had to go further, especially in math. But why bother? I know it's the right answer. Where is the asteroid belt found in the solar system? Between Earth and Mars? Nope. Mars and Jupiter. Okay. Some matching. Spiral galaxy, I think E. Yeah? Elliptical galaxy, I think A. Irregular galaxy. A mix of newly forming stars and old stars? Probably. I'll come back to that. A galaxy is definitely B, a collection of stars, gas, and dust held together by gravity. A nebula is a cloud of gas and dust. Celestial bodies are objects that orbit a star. So, what haven't I used? Yeah, you know what? I think G. G. Yeah, what's the difference between the rotation and the revolution of a planet? Okay. Rotation is the spin. I'll give you a formal definition first about the axis, but if you just said that rotation was the day, I'll give you 1 mark for that. Spell it right, Mr. Dueck. Revolution is the path around the sun. So if you said revolution is a year, I'll give you that as well. So Earth has a rotation of 24 hours and a revolution of, well, how long is a year on Earth? Roughly. Is it exact? That's why we have to have leap years every so often. So we have a leap year every 4 years, but that still doesn't quite work. If the year is dividable by 100, like 1900 or 1800 or 1700 or the upcoming year 2100, even though 4 goes into it, there won't be a leap year that year. However, if the year is divisible by 1,000, there will be a leap year. So the year 2000, although it's divisible by 100, shouldn't have been a leap year, but it's divisible by 1,000. It was a leap year. And then there's one more obscure one that you have to take care of every 15,000 years or so, but I don't plan on being around. Pardon me? 2016 will be a leap year. 2100 won't be, even though 4 goes into it. So if you guys are around in the year 2100, you guys are all 2000 babies. Some of you might live to be 100. The year 2100 won't be a leap year. 2196 will be, and 2104 will be. 2100 won't be. Hey, what are the 3 conditions a celestial body must satisfy to be considered a planet? Or a star. So let's make it general. Orbit a star, in our case the sun. Condition number 2, Kev.
Push itself into a spherical shape.
I'll say pull itself into a sphere. Pluto satisfies those 2. What's the 3rd condition? Yep.
Clear their orbit.
Clear its orbit from debris. Clear its orbit out. So however you phrased it, those are the 3 conditions. Which one does Pluto not satisfy? That one. And I also showed you the other issue was we had found several celestial bodies bigger than Pluto. Did we want more planets than 9 planets? We had to say, okay, let's come up with a definition. There is a possibility that there are 1 or maybe even 2 more planets way out there because there is some things that seems to be deflecting comets and nudging celestial bodies out there, but that's so far away, it's all guesswork. You guys, in your lifetime, they might find 1 or 2 more well past Pluto, well past Neptune. Can you give yourself a score on this quiz, please, out of 28? Add them up. So last day, I also gave you the crossword. Okay, I will throw an answer key up on the website in a few days, but I think you can probably get most of these words. Anyhow, these are your vocabulary words. This is due the day of the test. But we are going to move on. We're going to continue on. We're going to look. We started out, I don't know if you recall, Jordan, at the very beginning of our astronomy unit, I said we were going to start out big. The universe is expanding. Then we zoomed into the next biggest thing, galaxies. Then we zoomed into the next biggest thing, stars. Then we zoomed into solar systems. Now we're going to zoom into the Earth and planets. That's the plan. I don't know. Let's see. When is the test going to be? A week from today. A week from today. Okay? So section 12, we're zooming into the Earth. Chapter 12, we're zooming into the Earth. Phone away, please. Permanently. What are we going to learn about? Eclipses, solstices, equinoxes, and seasons, and then space exploration and technology. We may even talk about alien life out there, the possibility if there is or if there isn't. She's the alien life? Okay. So, what are some of the ancient uses of astronomy? Let me get my hand out so I can kind of follow along. Astronomy the stars have been studied by most cultures in the ancient times. First of all, they used it to keep track of seasons. Why would you want to keep track of seasons 3,000 and 4,000 and 5,000 years ago? Yeah.
To prepare for like the cold season.
and planting and when to, yeah, that was right around when we were moving from being what we call hunter-gatherers, where we chased animals, to, oh, we can live in one place and grow crops, which totally changes society. So looking at when to plant, harvest, hunt, also when natural events such as floods would occur. So Egypt, for example, the Nile flooded quite regularly. You didn't want to be there when the Nile flooded. Calendars. Native Canadians and other cultures had a 13-month calendar. How many months do we have?
12.
By the way, 12 is stupid. Anybody have a calculator here? Do you? Okay. Why 13? Can you go 28 times 13, please?
364.
How many days are there in a year?
365.
If we had every month 28 days, exactly 4 weeks, and we had 13 months, that would be a much nicer calendar. You would just have one extra day, which would be easy to keep track of. In fact, you could put it maybe right before New Year's and have like a little holiday, or have it go into New Year's or something like that. A year of 13 months, 28 days, and that would also be nice because that would mean April 7th was always on the same day of the week, because 28 days, the weeks just work out evenly every time, as opposed to now every year, hey, what year? Well, today is May 5th. What day of the week will May 5th be next year? I don't know until we get there, really. So this has been proposed, and in fact, some companies have even gone with this. The other reason this would be nice is if you're a business, this is great for accounting. Right now, some days are 31, some days are 30, some days are 28, and some days have more weekdays than other days. If you're a business trying to look at your sales, it means that you can't compare the numbers from month to month very easily. But we're stuck with it. Yep.
What would the 13th month be called?
Mateo. I figured that's where you were going with this, so yeah, there you go. Okay. So some cultures have, our calendar really, I gotta be honest, Lexi, is kind of stupid. It's kind of stupid. Who speaks French? Okay. The number sept.
7.
7? Oh, so that would mean September is the 7th month, right?
No.
Count it.
The 9th month, zillion 9.
What?
It's my birthday.
What does oct mean? Like an octagon. How many sides does an octagon? 8? Oh, so that would mean October is the 8th month, right? No, it's not. Yeah, see, we got a really dumb calendar. Beatrice said they added months. They did, yeah. We could have done better. If we were doing society now, I would certainly lobby for a 13-month calendar, each month, 28 days, very nice. And that way you would always know. Now, the only problem would be, what's the first day of the week? Sunday. Now, if you started every month with the first day of the month being Sunday, every month would have a Friday the 13th. Do the math. That'd be kind of cool because you'd have 13 Friday the 13th. Anyways, okay. What else? Next word you can fill in? Navigation. So far, keeping track of seasons was the first blank. Calendars was the second blank. Navigation is the third blank. There's an old poem that says, "Give me a ship and a star to steer her by." They navigated with the stars. So mariners sailing on the open ocean used Polaris, which is the North Star, and other constellations to get their bearings. Hunters, sailors use traditional methods, and they can tell where they are on land by looking up at the sky and use the constellations like a map. The only issue you do have to remember, though, is if you're in the southern hemisphere, you're looking at different stars. You guys okay? So, put your pencils down. The North Star, like that. Some historical sites. So in China, this temple was used to measure the length of a year, and they were accurate to within 26 seconds, which is pretty good. 300 years before Europeans managed to do it. It measured it by using shadows and the sun's shadow and things like that. This is the Bighorn Medicine Wheel in Wyoming. During the summer, 3 of the pairs of cairns, big piles of rocks, there's 1, there's 2, there's 3. 3 of them line up with the dawn rising of 3 important stars in Cheyenne mythology. in Newgrange, Ireland, for 17 minutes on the winter solstice and a few days on either side, light shines through a gap and illuminates the chamber inside. The light moves towards the back of the chamber and then forwards again. It was built about 5,000 years ago. Back then, we've done the math, the light would have reached completely to the back of the chamber, but now it stops about 2 meters short of the back wall because the Earth's tilt has changed just slightly. And that's enough to not quite have it line up anymore. Still, very impressive engineering. Right, Lena? This is in Peru. There are 13 regularly spaced towers. I told you that some cultures liked 13 months because mathematically it sure works nice. From the buildings at either end, you can see the sun rise and set in the gaps in the towers, with the sunrise moving back and forth across the entire structure in a year. So we think maybe this was an ancient calendar. So, ancient theories, back to the notes, of the solar system. Ancient people thought the sun and the stars revolved around the Earth. Why? Because that's what it looks like. You all know better, but you can see that from us, it does look like the sun moves across the sky, even though we know that's not the case. And it does look like the moon moves, well, the moon does move across the sky. This is called here's your word, a good vocabulary word for the chapter 12 test, the geocentric model. Geo means earth, centric means centered. For many years, astronomers believed the earth was the center of the universe and everything revolved around the earth. Aiden says, well, I like to think I'm the center of the universe and everything revolves around me. You're not that important. However, Nicholas Copernicus realized in the 1500s that here's another good word for you, heliocentric. Helio is the Greek word for sun. Yes, that's where the word helium comes from, because the sun has lots of helium. Sun-centered model made more sense. Galileo Galilei confirmed his observation 50 years later, but he was put on trial for heresy. Heresy is a fancy word for crimes against the church, because at that time the church ruled Europe and they taught that the earth was the center of the universe. In fact, Copernicus was smart. He knew that the earth went around the sun. He wrote a lovely book about it, but he didn't publish it till after he died because he didn't want to get in trouble. Galileo got a copy of the book and said, "This is right," and made a big stink, and he was thrown in jail, put under house arrest. Yucky history. What's the other? So the sun is one of the big objects at night in the sky. What's the other really big object at night in the sky? The moon. So the moon orbits the earth. There's the word that goes in that blank. The same side always faces us. We call it the near side of the moon. We only know what the other side of the moon looks like by sending satellites, or the Apollo astronauts flew around the moon, the backside of the moon, and took pictures. But we never see it. The moon reflects light from the sun. It doesn't have its own light source. It's just bouncing the sunlight back. So we always see the portion of the moon that is facing the sun. Is there actually a dark side of the moon? Well, no, that part of the moon, it just means we don't see it, but it gets light too. Pardon me? Yeah? Well, it depends what you mean by the word dark. If you go there, it's not like it's pitch black or anything. The Pink Floyd album, you actually guys, because I had a slide in here talking about the Pink Floyd album and I removed it because I thought there's no way you would know about it. Okay, you just impressed me. Where we believe the moon came from, the origin. Where did the moon come from? We think around 4.5 billion years ago, a Mars-sized object, a planet that's no longer around, slammed into the Earth, breaking off huge pieces of both planets. These pieces ended up orbiting the Earth. Eventually, their gravity pulled themselves together, and they formed the moon. You know what? A video is worth 1,000 words. So, what's the evidence for the impact theory? Well, one thing we've noticed is that moon rocks and Earth rocks are very similar. When we analyze the moon rocks that the NASA astronauts brought back, they're about the same age, they have roughly the same makeup. We're not sure on this, though, because there are some differences that we still need to think about, but this is our current theory. If you haven't already,
Then, like, for other planets, is that how the moon was made?
so is that how other moons on other planets were made? Some possibly, some could have just actually been from debris. The big issue is our moon is very large compared to most of the other moons, and it's very large around a smallish planet. Jupiter has and Saturn have some large moons as well, but they're huge. So we can easily imagine them sucking a small asteroid in and just getting it to orbit in a stable orbit, becoming a moon. Earth, not so much. So you've asked me a good question. I'll have to do research and find out. Thank you. We can see lots of detail. If you haven't looked at the moon with a pair of binoculars, you need to look at the moon with a pair of binoculars. It's spectacular. You can see the craters, you can see hills and valleys. It's amazing, especially on a nice full moon. Even with the naked eye, you can see some detail. So light areas are older and highly cratered. Dark areas are newer and flatter. We believe they are formed by ancient lava flows. Craters are due to collisions with asteroids, meteoroids, etc. Why does the moon have so many craters? Well, first of all, Earth gets hit by lots of stuff too, but most of it burns up in the atmosphere. Does the moon have an atmosphere? So there's, first of all, that's a problem. And even if rocks do hit the Earth, we have wind and rain and water and erosion that will gradually wear the craters away. Does the moon have wind and rain and erosion? No. So any craters that show up, they stay there. They stay there. It gives us a nice way to look at the moon's geologic history. Turn the page, if you haven't already. Oh, lots of craters, so no atmosphere to burn them up. Once a crater forms, it stays there as there is no moving air or water to wear them away. So we see, what do we see when we look at the moon? We see sunlight. Is that okay? Oh, sorry. Yeah. Okay. We see sunlight reflecting off the moon from different angles, giving us the bit more. Okay. I'll come back if there's anything you guys missed. Just remind me. I think we're still okay. Do-do-do-do. We see sunlight reflecting off the moon from different angles. Sunlight. And this is what gives us the, at different angles. This is what gives us the changing appearance of the moon. The moon doesn't change. It's just the parts of it that we can see get hit by the sun from different angles. And we call this changing appearance the moon's phases. What do we call it when the moon is its brightest? Okay, full moon. Okay. What do we call it when you can't see the moon at all? New moon. So we go from a new moon to a full moon. Then there's quarters, there's waxing and waning. I'm not going to ask you about waxing and waning and gibbous, and I'm not going to worry about that. Should know what a full moon is, should know what a new moon is. What are the main effects of the moon on us? Well, first of all, calendar. Our months are roughly the length of one moon full cycle. A lunar cycle is, it's not a coincidence that our calendars are roughly 4 weeks, but I've told you our calendars are kind of stupid. Should be exactly 4 weeks. And the other big one, tides. The water on the earth is attracted to the moon because the moon has some gravitational pull, and basically the oceans then slosh back and forth as the moon goes around the earth, and that causes the tides. I'm going to pause for a second, I think. Look up. What we want to talk about, I already showed you the video, How Far Away is the Moon, last class. What we want to talk about is how the seasons work. And if you ask me what's one of the key things I want you to come out of chapter 12, what am I going to ask you on the test? Absolutely, as a little, I'll call it an essay question, but it doesn't have to be, you can write it in point form. We want to explain how the seasons work. And here's my question for you, because a lot of people get this wrong. Why is it warmer in the summer and colder in the winter? Do you know? Why is it warmer in the summer and colder in the winter? The Earth's axis? What do you mean by the Earth's axis? Okay, it has to do with the Earth's tilt. A lot of people will say, and this is the big error that you don't want to say, oh, it's because the Earth is closer to the sun in summer and further from the sun in winter. Actually, it's closer to the sun in the wintertime. What makes the Earth's seasons? It has to do with the fact that the Earth is tilted. And sometimes that tilt means that the northern hemisphere is pointing more directly towards the sun, summer. And sometimes that tilt means that the northern hemisphere is pointing away from the sun, slightly, winter. That's the key idea. What causes the seasons? I'm going to ask you on your test to explain not just what causes it, the Earth tilt, but how. And as a start, we'll go with Bill Nye. This is about a 22-minute video. It'll take us right to the end of class, and then you can finish all the other stuff for homework.